So we've been absolutely loving our Starlink setup. It's allowed us to really get way off the beaten path where these overland trucks like to be. But one of the big issues with it is it isn't powered by DC. So today we're going to be hooking this baby up with some DC power, either 12, 24, or 48 volt systems. Pretty simple. In addition to that, we're going to be able to ditch this router in favor of a more capable router that even has a built-in cellular modem. Let's get to it. So you may be asking why go through all this trouble. For us, it comes down to a bunch of different things. First of all, it's important for us to have a little better router modem setup. These more advanced modems like a MoFi or PepWave will allow you to put in cellular SIM cards, and you can even prioritize and even switch between the Starlink and your cellular SIM card. It can even do load sharing, where it will actually split the load between your Starlink and your cell card. So there's just a lot of advantages of getting a little higher end router setup. In addition, the Starlink comes with a pretty massive long set of cable that's permanently attached to the dish. And this was just too much for 99% of the time we're using it. So we still want to have this as an option, but we want to be able to add it in when we need it. So instead, I just ran about a 15-foot tail on this, which is enough for us to just get it off to the side of the rig, or in most cases we just leave it up here on the roof, and this is just the right length for that, and then I can add that additional length in should we need it. As well as the fact that running it off DC is going to be a little bit more efficient. I tried to run the numbers on how much power it draws with the AC system, but it fluctuates a lot just the way these dishes work, so it's hard for me to get kind of a concrete number, but I have no doubt that it's going to be a little bit more efficient running it this way. Plus, it just frees up another outlet in the rig and just one less component that I can get rid of and clean things up a little bit. So first off, let's talk a little bit about the regular Starlink setup and how exactly it works. This here is the Starlink modem, and to the bottom of this you'll attach your 110 AC power, as well as the cable that comes from the dish with their kind of proprietary connector. That also goes in the bottom. And that's it. It's a pretty simple system. What's unique about this router is that it actually provides power to the dish by way of this main cable. That's kind of the catch. That's why we can't just simply throw on an RJ45 network end and then plug the dish into a standard router like this, because this router is not designed to send power up this cable to the dish. So that's the key to this whole system and this kind of hack of getting it off the AC power onto a DC system, is we need to figure out a way to provide power up to that dish. And of course there is something designed to do that. It's called a PoE, Power over Ethernet. What this little device does is you plug in your Ethernet cable on one end, like so. This one goes to the dish. This one goes to your router. And then you hook up a power supply, which plugs in here. This particular power supply I have is a 24 volt to 48 volt converter. The Starlink system runs on a 48 volt system. So whether you want to go from 24 to 48 or 12 to 48, or if you have a 48 volt system, then you're good to go without even a converter. But they make these for any type of conversion that you need. So now what we have with this system here, we have power going to the dish to make it do its thing, power it. We have a standard network cable. You can now plug this in to any modem out there. Just the most simple basic modems you might have in your home to some of the more sophisticated ones like this that also have cellular antennas in them. But this is just a standard network connection, so the only thing missing, of course, is we just need to provide power here, in our case 24 volts, to the system. So that's the goal of this, is to eliminate this AC device in favor of this that can now plug into any type of cellular or standard modem. So that's what we have. I just wanted to show you kind of the finished project, and let's get down to wiring and how these fittings work, because these are not standard network fittings in terms of how they are wired. So the actual order of the wires is not standard to the network system. So there is some kind of tricks and different order of wire that we have to be aware of. So let's go downstairs inside and we'll wire up a few of these fittings to show you how that all works. I also wanted to mention another way of doing this that's a little bit less destructive, and that you could return this whole system to normal. For me, I wanted to cut that main cable because I wanted a shorter cable. I didn't want this long spool. I think it's about 75 feet, and it was just kind of a hassle dealing with it every day. But there is an option to keep this entire cable but still delete the stock router and run it off DC. Starlink sells an Ethernet adapter. It's basically a box that looks very similar to this little guy here. This will plug into that, and then on the other end of the box it has just a standard network fitting like so. Now you'll still have to rig up all this powering system for it, because that Ethernet adapter does not power the dish, but it does allow you to maintain this same end without having to cut the main cable. So that could be good for folks that are afraid to, they want to have the option to return it back to normal. So I'll give you some diagrams and drawings for that, and that option will be up to you. I think you'll see that's pretty straightforward how this all goes together, but I just wanted to let you know that that is another option for you. Another perk to going this route is I wanted to find some clean ways of having penetrations through the side of the camper to be able to plug this in and not have to run the wire through windows and doors and such. What I actually found was this kind of weather sealed connector like so. Unfortunately, it was advertised as shielded, which we'll talk about more later, but these cables are all shielded. This, however, was not shielded. It doesn't pass through the shielding from the connection, so I'm going to return this and have to search for another one. But it's going to make for a really nice clean install, that we can just have this little guy mounted to the outside, and our external line will just plug in like so. The other piece that we're going to be using is this kind of weatherproof connection. And so this will be how we just extend added lengths of the main networking cable if we need to get that dish further away from the truck. So I've got a couple of these that will fit to the end of the cables and make it really easy and watertight when we need to add more into the system. All right, let's get to it. So here's the drawing of the setup that I'm going to be using. We've got our 12 volts coming in to that DC to DC converter, which is going to step it up to 48 volts. That plugs into our PoE device, this black box here. And then we've got our Ethernet cables that will plug into both sides of the PoE box. One side is going to go to the router, and that cable will have one swapped in and one standard end that plugs into the router. And on the other side of the PoE, we have the cable that is going to the dish. And I'm going to cut that dish cable so it's going to appear just like it in this image, where I will wire the connector to this swapped wiring order. And like I mentioned, one option is to, instead of cutting the hardwired cable from the dish, you could wire that Starlink proprietary connector into the Ethernet adapter that you can buy from Starlink. And then from that box, you would then run this configuration into the PoE injector. So first I wanted to go over basically what's inside of these cables. Now, the Starlink cables must be shielded. Basically what shielding is, you'll see it here in a minute, but it has some extra wire along the sheath of the housing that just helps with, I'm not even sure exactly what it does, but for the most part I think it just helps with interference and whatnot. But just to show you on a simpler cable, I just wanted to use this as an example for now, and then we'll open up the shielded version. So when you open up one of these cables, you have 4 pairs of wire. There's a brown and white paired together, a blue and white, a green and white, and an orange and white. If all of the whites are completely white, so if we unwound all of these and put the whites all together, you wouldn't be able to tell the difference. The whites aren't individually marked. So it's important to kind of keep things paired up until you're ready to make the connection. And basically what we're going to do is there's a standard order for these, and then we're going to be doing a slightly different order of these, which will then slide into this connector, and that's kind of the magic. So we just have to get the right order, and that's what will allow this system to work. So again, it's important that this cable be shielded. I'm just using this non-shielded one as an example just because it's a little bit easier to see. And you'll see in the diagram, it's also important to note the numbering from 1 to 8 for the order of these clips. If you can see the contacts and they're facing towards you and it's pointing up, 1 is on the left and 8 is on the right. So you can see the number 1 to 8 on the connector, and so let's go through and we'll just do the standard 568B order of wiring, which is what's going to go into the router. So you can see pin number 1 is going to be the white and red dash, okay? Like so. The next one is going to be, orange, the white and orange pair. So the white of the orange pair goes first, then it's going to be the solid orange. Next, we have the white from the green, which is that dashed green. And next we have the solid blue. Next we have the dashed blue, which is the white from the blue pair. Next up is the green. Next up is the white from the brown pair. And then we have the solid brown. So that's how you get the order of these connections. And then you just have to really carefully feed them into this fitting to keep that order. Now let's go ahead and do one for real here. Okay, so we're just going to strip back the wiring like so. So here I am opening up the actual cable from the Starlink. You can see how it has that kind of similar shielding tinfoil. Here's the shielding individual silver wire, and then all of the pairs of the wires are grouped just like we saw earlier. So I'm just going to trim away this plastic and this foil. So again, this is going to be a swapped RJ45 order connector. And so we're going to start with the white from the orange. And these are easy because these are actually labeled correctly. So the white has a little bit of an orange checker to it. So we're looking for an orange checkered is in spot number 1. We've got a solid orange coming next. Next up we have the solid blue. Next up we have the checkered green, or the white from the green pair. Next we have the solid green. Next we have the white from the blue. Next we have our checkered brown, or the white from the brown, and we have our solid brown. Okay, so I'm just kind of working my way down the wires, just getting them to lay nice and flat. I'm just kind of inching my thumb down here, and then once I think I have enough space, I'll just go ahead and clip these. Check the order one more time. And then we'll try sliding them into the connector. Okay, so I'm going to go ahead and cut these nice and square. Okay, I'm just going to go ahead and double check the order. I've got the white orange, solid orange, I've got a solid blue, I've got a white green, solid green, white blue, white brown, and then the solid brown. And pin 1 is to my left, which corresponds to pin 1 as I put it in the connector here. Slide my hand back. Okay, so we've got all the wire through. This, these are going to be really nice to double check that we have the correct order, because the white ones are actually labeled. I'll link in the description all of the stuff I used to do this, but I'm not going to link the Cat 5 cable I bought because it doesn't have the wires labeled, which I think is kind of a pain. So anyways, I've double checked these and they're in the correct order. So now we just get to the crimp, and again, this wire just kind of needs to be tucked up and in contact with these metal pieces here. Some of the Cat 5 connections actually allow that wire to be crimped to that outer casing, which is a little bit nicer, but these just don't offer that. I'll probably pry this up a little bit and fit that under there. And then as this slides on, that metal is just going to mesh with this shielding, and I just kind of tuck it up in there like so. That looks good. Now it can go inside the connector or the crimper, and you'll see here as the crimper crimps it, it also shears off the ends of the wires. Okay, so that's been crimped. And we've got a swapped fitting. So if this was the wire from the satellite dish, let's just wire this up, kind of pretend. So I have a swapped fitting that goes onto the back side of the PoE. The regular fitting here goes into the router. The power that's going to power the dish gets wired into this spot here, 48 volts. And then the swapped end goes to the dish. Okay, so this cable is connecting to the dish. Okay, so now that we're finished with everything, I just wanted to show you one last shot of the finished system here. So here's our dish, and you can see I have that shortened spool of line which connects to that PoE injector. We've got that powered by our 12 or 24 volt to 48 volt setup. This here is one of the swapped pinouts that I talked about. This is another swapped arrangement of wiring. This is a standard arrangement of wiring. Here's the original cable with its little proprietary end, and then I'm going to just be chopping this end off and adding a swapped configuration to both ends, which I can then connect to the system with this, and then eventually I hope to find one of these that's actually shielded that we can use for the exterior of the truck. Cheers, you guys. Finished another project. I hope you got something out of this. We've been using it for, we've got a good week on it, and it's been working great. I absolutely love it. It's just nice to simplify things. Plus, these buggers are selling for a few $100 on eBay, so that's going to be getting listed here in a bit, and we'll pay more than enough to pay for all of this extra equipment we had to buy. I've got links in the description for all of the components we used. I'm also going to get a little blog article written up on our website over at outsidenomad.com, so if you want to see some more write-up and specifics, and in particular those wiring diagrams for the swapped configuration on the RJ45 network cable, I'll have all that on there as well. But I did leave some links to those images in the description for the video. So anyways, thanks for watching. See you on the next one. Have a good one.